Alright guys, we are looking at an Mk5-pfc2. Discovered some new things about this, working very hard on this board this week. I'm going to add the new things along with the old things. I haven't actually made a video in a while, so see if you can follow along with this. And this is actually for my own education too. Let's start at the very beginning. Power. AC line comes in right here. Come on, focus. There you go. Power comes in here. You do not have to hook up this guy to the filter board. You can clip wires on here and feed it 120 AC. That goes through some filters and ends up at the bridge rectifier down here. Gets converted to DC. Charges to peak voltage because the DC is fed directly into V bulk, which translates to about 170 volts DC if you're running on 120 AC. Not sure what it is on 240, but this power supply can run on both. The next thing that happens though is that 170 volts DC feeds into that little guy right there. And his job is a mini switched mode power supply. So basically an oscillator. And it works with this coil L10, and it hits this with high frequency, and the collapsing field on L10 is rectified by two diodes, one right there and one right there. So that'd be a D20, D19. Okay. And that generates around 13.6 volts DC, and it's filtered by this 100 microfarad cap. That is within respect to V bulk ground, so you got plus 13 volts. And if you look right there on that little golden hole, I'll see if I can get that. Yeah, there we go. That little golden hole under that big power resistor. That's a good place to tap to test for 13 volts. If you're not getting 13 volts there with respect to capacitor ground, then this capacitor ground or this one, honestly they're the same. They should be the same ground. Then check your chip, check your coil, check those diodes. Probably wouldn't be a bad idea to swap that capacitor anyway. I don't know why this thing is being so hard to focus. Sorry. New phone. Anyway, another place, a good place to get negative is right here off of this resistor on the orange side of that power resistor. Alright, now VCC powers up this chip, which is your main controller, your Texas Instruments UCC chip. It also provides power to this quad op amp chip, and provides power to the which one is that? That's the one second. That is the U5. Yeah, U5 right there. And that powers the optic isolator there, which receives feedback from these safety circuits right here. Now, what's interesting about these safety circuits, though, is that they are on the secondary side. So they cannot receive VCC power from the same power rail. That would violate isolation. So what happens is they get their power from this filter capacitor via these resistors, which step down secondary voltage and goes through D26 to get converted to DC, filtered by this capacitor. And that capacitor provides all of the VCC for the chips on the secondary side. Okay, now coming back to the primary side though, this one monitors several safeties, including this optic isolator, which is the final phase of all of the secondary safeties. So if any of these are tripping for any reason, that's going to send this thing into conduction, and then when that's conducting, that's going